Dear friends, Auzubillah minash shaitanir rajim, Bismillahir Rahmanir Rahim. This is continuation of the lecture, Contribution of Muslims in Astronomy. So this is the third lecture. Persia, which after the downfall of Abbasid caliphs formed the nerve center of Islamic learning, produced some of the greatest intellectuals of medieval times. Great advances were made in almost all branches of the knowledge. One of the most outstanding intellectuals of Islam was Abu Rehan Brunei, 973 to 1048 AD, who graced the literacy meetings of Mahmud Ghazni, Afghanistan. Few know physics and metaphysics, say J.N. Sirkar, the celebrated Indian historian. Amongst those few, the greatest in Asia was Al-Biruni. At once a philosopher and a scientist in both of these two seemingly incompatible fields. Al-Brunei was distinguished and original scholar of astronomy and other sciences. His Al-Qawm al-Masudi, written for his patron Sultan Masood of Ghazni in 1030 AD, is an astronomical encyclopedia. Geometry, arithmetic, astronomy, and astrology, also written in 1030 AD. The rotation of the earth on its axis and the accurate determination of longitude and latitude were also elaborately discussed in this book. Malik Shah Seljuk and his illustrious Grand Wazir Nizamul Mulk Tusi were also great patrons of learning during those times. These established an observatory at Ray or Nishapur in 1074 to 1075 AD, where under the guidance of Umr Khayyam and Abdul Rahman al-Hazini, astronomical observations were made. Their research led to the reformed calendar, which preceded the Gregorian calendar by 600 years. According to Sedilot, who is an authority on the subject, he says it's the time, it's most exact. This calendar formulated by Umr Khayyam was named Al-Tarikh Jalali after his patron Jalaluddin Malik Shah Seljuk, and is based on an accurate determination of the length of the tropical year. The Gregorian calendar leads to an error of one day in 3,330 years, whereas Khayyam's apparently leads to an error of one day in about 5,000 years. The destruction wrought by the Mongol hordes served a death blow to all cultural and intellectual movements in the world of Islam. The cultural treasures amassed during centuries of intellectual pursuits was reduced to ashes. On the downfall of the Abbasid Caliph, there sprang up small Muslim principalities who kept aloft the candle of learning and vied with each other in the patronage of scholars and scientists. A year after the fall of Baghdad in 1259 AD, Halaku Khan started the construction of the Khani's Observatory in the Marga, Turkestan. This was the best observatory of its time, working under the directorship of the celebrated genius astronomer of that era, Nasiruddin Tusi, and equipped with the best available instruments, including an armillary spheres, the moral quadrant, and a scholastic armill. The remains of this observatory are still extant, and it was here that Tusi compiled the famous astronomical tables known as Al-Zij. which earned much popularity throughout Asia, including China. Nasiruddin Tusi also wrote Tazkirish Film al-Hay, an outstanding work on astronomy. Samarkand, the capital of the famous conqueror Temurlan, became in those days the great center of Islamic education. An astronomical table prepared in 1437 for a prince of the family of Temurlan and the called tables of Ulugabeg was much appreciated in Europe, and according to Caras de Vaux was published in England in the 18th century AD. The Arab civilization of Spain revealed that of the Abbasids in the east, and during the middle of the 10th century, astronomical studies were especially favored by the rulers of Muslim Spain. The outstanding Spanish astronomers were Al-Majriti of Cordoba, Al-Zargali 1029 to 1087 AD of Toledo, Ibn Afia, whose death was in 2140, of Seville, and Nuruddin Abu Ishaq al-Bitruji. In his famous work, Kitab al-Hayat, Book of Astronomy, which was later translated into Latin by Girard of Scrivener, Jabir ibn Afra, the celebrated astronomer of the 12th century, sharply criticized Ptolemy. Against the observation of Ptolemy, they rightly observed that the lower planets, Mercury and Venus, have no visible parallaxes. His generalizations of the subject were confirmed by later research. Al-Zarkali, from 1029 to 1087 AD, was the foremost astronomical observer of Muslim Spain. He was the celebrated instrument maker who constructed an improved type of astrolabe on which he wrote treatise. His calculations of the length of the Mediterranean Sea as 42 degrees was approximately accurate in comparison to Ptolemy's estimate of 62, and Al-Khwarizmi, whose estimate was 52. He also has the distinction of being the first astronomer to prove the motion of the solar apogee with reference to stars. His work, along with those of Al-Battani, were studied and appreciated in the West, and Copernicus quotes him in his well-known work De Revolution Orbisum Coelestium. Nuruddin Abu Ishaq was foremost among the last astronomers of the Spain, whose outstanding work Kitab al-Hay was translated into Latin by Michael Scott in 1217 and into Hebrew in 1259 AD. He is considered the exponent of a new astronomy, and his book marks the culmination of the anti-Ptolemy's movements. According to Draper, increased accuracy was given to the correction of the astronomical observations by Alhazen's great discovery of atmospheric refraction. The first observatory in Europe was built by Arabs in Seville. The famous astronomical tower of Seville was constructed under the supervision of Jabir ibn Afia in 1190 AD. With the fall of Muslim power in Spain, it was turned into belfry by the Christian conquerors who didn't know what else has to do with it. Finally, it was through Spanish channels, says Philip K. Hathi, that the Latin West found its Oriental inspiration in astronomy and astrology. The leading Muslim astronomical works were translated into Spain into Latin, and the Alfonso tablets and Alphonsine tables compelled under the aegis of Alfonso. According to R. Briffault, Arab astronomy did not foretell Copernicus or Newton, though without it there would have been no Copernicus and Newton. So, this was, my friends, about last lecture of astronomy. Keep on watching.